we will use Laplace transform to solve this initial variable problem. So first we transform the equation using Laplace transform. And we have second derivative, so we use this formula, which turn into s squared y of s minus s y of 0 minus y prime of 0 minus 9y. The transform of y is just the function of s. The right hand side we have 45. The transform of t, we use this formula, and so we have 1 factorial over s of 1 plus 1, 1 factorial s of 1 plus 1, so s squared. And then 24 e to the negative 3t, we use this form of the Laplace transform, will be 1. It will be 1 over s minus 3 will be s plus 3. We have the initial values y of 0 equal to 0. Derivative is equal to 11. So now factor out y of s, we have y of s squared minus 9. The 11 we will move to the other side. Negative 11 becomes 11 on the other side, and then we have 45 over s squared, and then 24 over s plus 3. This is a relatively long problem and tedious problem as well, so I already wrote out the calculation. I'll just go over that again, for the first time. Right. So first we will divide s squared minus 9 on both sides. Divide s squared minus 9 on both sides, and we have this. After that, we multiply the denominator out, and then combine the denominator. We should have up to this stage. After that, it is the partial fraction decomposition. We have s squared, which turn into this decomposition. I should not put anything in the box. S minus 3, S minus 3 turn into this one here. S plus 3 squared turn into this 2. Right. After that, we multiply the least common denominator. That will eliminate the denominator, and we will have what we have in this line right here. Right. Multiply everything on the left hand side. I wrote down earlier, so we don't have to do that again. However, the next step is to combine like terms. I'm going to do this one again, because that is very important, the technique of it. So first, if we have s to the 4th, I should use different color, s to the 4th, then we write out all the coefficient of s to the 4th power, including here. So that will be 1a. Next one doesn't have it. This one has his with c, so a plus c, and then d. That is s to the 4th power. Next, we go to x cubed. We write out every coefficient of s cubed will be 3 s cubed with the a, so we write 3a. The s cubed here, 1 times b. No s cubed for c, no s cubed for d, and s cubed for e. So we do like for E, of course, 1 times E. And then we go for S squared. Right. That is, if we write correctly, I think this should be the 6x cubed. So in that case, indeed, we do have a 6c. Sorry. So again, we have 3a, a b, and a 6c. And 1e. And now the S squared. We have negative 9a. That's right. For B, we have 3c. Again, don't forget we multiply by a. 3b. For S squared, we have a 9s squared here, so that would be 9c. Negative 9 here for D. Negative 9d. And then negative 3e. Let me check before we continue. Negative 9a, 3b, 9c, negative 9d, negative 3e. Right? We need different color. Now we have S. So for S, we have negative 27 times A, negative 9 times B, nothing for C, nothing for E, nothing for E. So that's all we have. And then the only thing left here is just minus 27b. As we see, everything we underline except for the negative 27b. And after that, we will match with the coefficient. So on the left-hand side, we have 11s cubed. So we'll put in the color code 11x cubed. We use that in green. The S squared, we're going to use red. The S, that in purple. And the only thing left is 135 equal to negative 27b. That I don't need to put in the box. So we have the system of equation. The one in blue here, of course, equal to 0 because we do not have x to the fourth on the other side. Right. So let me check this one more time before we move on. So with this system of equation, right. Again, this is a long problem, so I already write out the solution. Right, so we have the system of equation like that. And if we put in the calculator reduced row echelon form, and we should end up with this. So we say A is 0, B is negative 5, C is 2, D is negative 2, and E is 4. And so we have y of s in this form. All we need to do is do the inverse transform from here, and then we will have the solution. Right, the inverse transform. Then we go back to y of t. Inverse transform. I just write -5, and then we do the inverse transform of 1 over s squared plus 2 inverse transform of 1 over s minus 3 minus 2 inverse transform of 1 over s plus 3 plus 4 inverse transform of 1 over s plus 3 squared. If we look in the inverse transform table, the first one is the transform of t. The next one is the transform of e to the 3t. And then the next one is e to the negative 3t. And the next one, the last one, 4t e to the negative 3t. And this is our solution. Let me zoom out and go from the beginning and go over the whole problem again. Right. Once again, we transform the whole problem into Laplace transform, and so we're going to have this one. After that, we solve for y of s, and we have in this form. And then combine the right hand side into just one big fraction, because that one big fraction we will decompose that into a little fraction using partial fraction. And the calculation, we should have that, what we have here on this page. For the next page, we just solve that system of equation. Then we have all the coefficients from a to e. We have y of s equal to this equation, and finally do the inverse transform, and we have y of t equal to that function.